So, first of all, what is a polygon?
A shape that has all the sides.
It is. It is a multi-sided shape, yes. So a triangle, a square, an octagon, these are all polygons. Now, when we have a regular polygon, what makes a regular polygon? Whoa. All sides are congruent. So when, and all angles, yes. So when we have a regular polygon, which is all sides congruent. Oh, I thought you were a student, Travis. I'm like, yes, all angles. Good for you. Oh, good. No, it's fine. All sides congruent. We can use an area formula to find the area of this regular polygon. Now, before we actually find the area, we need to go over a couple of vocab words. On this polygon, I know mine's a little blurry, I'm sorry. On this polygon, we have something called an apothem. Where is the apothem in this polygon? Can you take a guess? The line that has a... yes, and it has a little A on it, right? It has this little A. A line in a polygon that goes from the center to the center of an edge is called an apothem. Now this is actually different from a radius because a polygon also has a radius. But where is the radius? Center to a vertex, right? An angle. So this is a radius. So on this shape has 6 sides. It has 6 apothems and 6 radius. Radii. Radii.
6 radius.
Radiuses. Also, on this polygon, we have sides, obviously, that have side lengths. We're going to call the side length S. Whoops. And we also have what is called a central angle. Now, last unit we learned, where is the central angle located? In the center. Now, on a polygon, the central angle is specifically the angle that goes from a radius to a radius. So this right here is a central angle. So on this polygon, how many central angles do we have? 6, right? The same as the number of sides and apothems, yes. Now, even if they don't give us any numbers in a polygon, we can always find the central angle measure. How? So, in the center of a polygon, we know that those angles have to add up to 360. So if we take 360 and we divide it by the number of sides, this will give us the central angle measure. And if you've forgotten, n is number of sides. Whoa. Also, on this polygon, how would we find perimeter, that big P? Yes, you multiply the side length by the number of sides, S times N. All right, so really, in order to solve for any of these polygon problems, we needed to know all of that information. Because when we're finding the area of a regular polygon, our formula is 1/2 the apothem times the perimeter. This formula right here, it's very important. So let's try it. The first one is kind of easy. I have all of these are regular polygons. Specifically, what type of regular polygon is this first problem? A regular quadrilateral, which this is a quadrilateral because it has 4 sides. A regular quadrilateral is a square. So all of the sides measure how much? The same, which is what in this problem? 4. So our side length here is 4. Knowing that all the side lengths are the same, what does that apothem measure? Yes, right? It goes from the center to the center of the edge. So it has to be half of 4, which is 2. So our apothem is 2 centimeters. Now, just because we eventually, for most of these problems, are going to have to solve for the apothem, we're not just given it like we are here, we need to know how to find the central angle. So in this problem, how would I find a central angle? Divided by 4, because there are 4 sides. Good. So what is 360 divided by 4? 90 degrees, right? That makes sense. We learned way back when in quadrilaterals that the diagonals, which this is part of the diagonal, form 90-degree angles. Now, if we know that central angle is 90, how much would this angle here be? Ah, yes, we cut the central angle in half. That's how you find the angle in your little triangle there. You always take the central angle divided by 2, which in this case is 45 degrees. Now, say we didn't have this 2. We now know that this angle is 45. We know that this bottom length here is 2, right, because it's half of 4. How would we find the apothem measure?
Doesn't that give you an angle and a outside?
Gives you an angle and a side, and we're trying to find another side. We have to use trig. Not in this problem, because this problem is way too easy. But in the problems we're about to do, yes, we're going to have to use trig. Now, how do you find the perimeter of this square? Yeah, 4 times 4, which is... And the area is going to be, now we can either use length times width, which we know works on squares, but because we're trying to, on this whole page, find the area of polygons, let's use our polygon formula, which will also work. So 1/2 times the apothem, which is times the perimeter, which is, what is 1/2 times 2 times 16? 16 centimeters squared.
And you have to write the square or whatever.
Oh, yes. Does that make sense? This is the easiest one. Really, I wish we hadn't put this on the paper at all. All right, guys. Let's try to find the area of this polygon now. What are we missing if we would want to find the area? Side length, yes, the perimeter, right? So, first, let's mark down what we do have. What is that 6? The what? The apothem, right? So 6 inches is our apothem. Shh. What about the central angle? What's the central angle in this problem? 360 divided by how many sides are there? 5. What's 360 divided by 5?
72.
72. And then how do I find this angle in our triangle? 72 divided by 2, which is 36. So what did we say we're missing if we wanted to solve the area of this problem? And therefore the side length. So I can use this right triangle here, which the apothem is always perpendicular to the side length, the side. How would I go about solving for this length? Trig. Do I have the radius measure? No. If I did, I could use Pythagorean theorem, but I don't. So I have to use trig. So where is my theta? Where is my O? Where's my A? So I have O and A. Which one? So, ka or toa has an O and an A. Tangent. Now what's my theta?
Theta 36.
What's my, now it's O over A, so what's my O? And what's my A? And I'm missing the top, bottom, or angle?
You're missing the top.
Top, so what do I do? You multiply. So I multiply in my calculator, which, what mode should my calculator be in? Oh, which mine is not. Make sure you check. You do 6 times tangent of 36. And you should get 4.36. Now, is this my side length? What is this? Half of it, right? We just used this right triangle to get this length right here. It is only half of your full side length. So what do I need to do with that 4.36? Multiply it by 2. Now, when I am multiplying this, am I going to, in my calculator, put 2 times 4.36? No. What am I going to do? Use the answer that you got previously, right? We want to maintain accuracy here. So you're just going to do 2 times your second answer there. 8.72 inches. Is it inches? Yes, inches. So now that I have the side length, what can I easily find? The perimeter, which is what? What do I multiply? 5. There are 5 side lengths, and what? I'm sorry, there are 5 sides. And what is my side length? So what is 5 times, now am I going to put 5 times 8.72? I'm going to put my previous answer there, 8.718510336 times 5. And I get 43.59. And what's my last and final step? The area. So 1/2 the apothem, which was 6 inches, times the perimeter, which was 43.59. And then you use, again, the big whole number. So you do that whole perimeter number times 6 times 1/2. And you get 130.78. Inches squared. Does that make sense to everyone? Any questions on how to find the area of a polygon? All right.